continuing chapter 7, and we're now talking about energy. So, energy in its everyday sense has something to do with whether or not you feel like getting out of bed in the morning, apparently. But its technical definition is not too dissimilar. Energy is the ability to make something happen, or more formally, it is the ability of something to do work. So, it's the ability of something to do work, which we spoke about in our last video. So work is equal to the change in energy of a system, and work is also equal to force times distance as well. So the amount of force required to move some sort of distance that requires work and energy. And the unit of energy is joules as well. Okay, so it's the same unit as work, and in some senses they are interchangeable terms. Whenever work is done, the same amount of energy is used. One way to think about it is energy is a universal currency. As money makes the world go round, energy makes the universe go round. Energy exists in various forms. For a word to be a name of a form of energy, you can ask the question, can something enable work to be done, i.e. can it apply a force and move something, or can energy make something happen? Can blank make something happen? Okay, so we'll have a look at some of the forms of energy. So chemical energy. We use chemical energy in various ways. So food contains chemical energy, chemical potential energy, and young adult males apparently need 10 megajoules per day, so 10 times 10 to the 6 joules, or 10 million joules. 10 million joules of energy per day, while females need about 8 times 10 to the 6 megajoules per day. The energy content of packaged foods is specified on the package, or you can look it up in Weight Watchers books. Okay, typical values are fats. These one. Okay, there's a bunch of different ones here. Examples. I encourage you to have a look on the back of your chocolate bars and things like that. If you're around 17, 18, you might not have to care too much about how much energy is in things, but once you get to 30, you definitely do need to care about how much energy is in different things, and you can't eat as many Tim Tams as you once were able to. Okay, so fuels. The chemical fuels are used to store energy, so petrol and liquid hydrogen, and gasohol is one I had to look up. It's a mixture of gasoline and ethanol, and probably various other things. And ethanol is like alcohol, type of alcohol. Okay, so fuels that go into our cars and things like that. A type of chemical energy. Potential energy. So we're going to look at potential energy. Potential energy, another hidden form is called potential energy. Potential energy is energy in an object. Potential energy is energy in an object has big. This is a weird sentence. Okay, because of its position or state. So potential energy is basically stored energy. So we call gravitational potential energy. So this one is actually in our formula sheets as half. No, it's not half. I'm getting confused with kinetic energy, aren't I? Get rid of that half. So potential energy is equal to mass times gravity times the height. So if you lift something up above your head and you drop it, let's say you drop it on top of your head, then that's going to hurt your head, because basically you've given potential energy to that object. You raise it up above your head, and then you dropped it, and then it gets transformed into what we call kinetic energy, which we'll talk about in a minute. And then that gets converted into heat and sound and various other things. But basically, whenever you lift something above the ground, you are giving it potential energy. The higher you lift it, the more potential energy you're giving it, because the higher you lift something above your head, the more it's going to hurt. Probably. Depends on the object, of course. Depends on the mass of the object. Okay, so gravitational potential energy is one form of potential energy. Elastic potential energy. So this is the energy stored in a compressed spring, an artery bow, and like an elastic rubber band. Once again, the work done in compressing or stretching the spring is the stored elastic potential energy, and the work the spring can do when it returns to its rest position all have the same value in joules. So, like on a trampoline, you are essentially you're converting your gravitational potential energy. So you jump up, and that gravitational potential energy gets turned into elastic potential energy, and then it goes back again when it lifts you up above the ground. That's how a trampoline works. Okay, kinetic energy. I spoke a little bit about. I just kind of referred to kinetic energy. So when mass is accelerated from rest, work done work is being done is done in increasing its speed. Okay, it's kinetic energy and the work that the moving object can do when it comes to rest all have the same value in joules. Okay, so kinetic energy is equal to half times mass times velocity squared. So the faster something is going, the more energy it has, and it's by squared. We square that factor. Okay, so this is quite intuitive as well. So let's say that you have someone walking towards you, and you can basically stop them with a hug or something like that. You can stop them with a hug, but if they're running towards you, they're probably going to bowl you over. So it takes more energy to stop someone that's going faster than if they're just going slower. So we can think about it in those kind of ways.